Our solar system is a savage place. From the ice volcanoes of Saturn's moon Enceladus, to the vast lava fields of Jupiter's Io, to our own world, the Earth. Volcanoes destroy. They also create.
It is literally true that if there weren't volcanoes here, we would not be here either.
Volcanoes shape and change our climate.
Volcanoes are the giver of life and also the takers of life.
Today's space probes and telescopes reveal volcanoes on worlds we once thought dead.
Finding volcanoes on an object that's smaller than our own moon was a huge shock.
If volcanoes exist on other worlds, could we find life there too? Planet Earth, a jewel in the darkness of space. Our home is timeless, beautiful, and incredibly violent. Volcanoes are one of the most powerful natural phenomena on the planet. They create new land, destroy the old. They blast out gases that transform the air we breathe. Deep in our oceans, volcanic heat fuels strange new life. Volcanoes help power the living Earth. Now we search for signs of life on alien worlds. We know life needs water. We know it needs energy. And that's where volcanoes come in. They pump out vast amounts of energy. Find volcanoes on other worlds, and we might find life. The search starts here. The planet orbiting closest to Earth, Venus, a world that appears very much like ours.
Venus and Earth are roughly the same mass, they're roughly the same distance away from the sun, so they're kind of like twins.
Three billion years ago, Earth and Venus were very similar. New land, new oceans, an atmosphere. Both planets were perfect for life. But on Venus, something went wrong.
Something made Venus diverge radically from the history of the Earth.
Venus took a definite turn to the dark side a long time ago.
Venus is a hellhole, our evil twin.
Today, Venus's surface is like a furnace.
It's 900 degrees Fahrenheit on the surface, and it's hot enough to melt actually some metals, so you wouldn't stand a chance.
Venus is a greenhouse world. Its atmosphere is thick with carbon dioxide. It traps heat from the sun like a blanket. These actual images of Venus's surface reveal a barren, superheated wasteland. Venus's thick blanket of CO2 killed the planet. The CO2 came from volcanoes. Orbiting space probes gave the first clues. Radar punched through Venus's thick clouds and revealed volcanic formations across the planet. like formations we also see right here on Earth. The shield volcanoes of Hawaii. Shield volcanoes get their name from their round, flat shape. These volcanoes ooze, but they ooze for thousands of years.
Once we were able to map the entire surface of Venus using cloud-penetrating radar, we started to study the landforms there, and we saw a lot that was actually very familiar. In particular, we saw giant shield volcanoes that are very similar to the shield volcanoes here in Hawaii.
The radar images of Venus were dead ringers for the shield volcanoes on Hawaii. Sometime in the past, Venus had volcanoes.
For the first time, we had a picture of Venus revealed. And boy, were we shocked. We found a scarred surface, a volcanic surface.
There are at least 1,000 volcanoes that are very large, and maybe tens or even hundreds of thousands of smaller ones.
3/4 of Venus's surface is lava plains, evidence of an ancient cataclysm. This could have been a home for life. Instead, it was engulfed by fire. Volcanoes belched trillions of tons of carbon dioxide into Venus's atmosphere. Temperatures soared. The seas boiled dry. A runaway greenhouse process began.
On Earth, carbon dioxide is able to absorb into the rocks, it's able to absorb into the ocean. But on Venus, you have no water, and it's now so hot that carbon dioxide can't even combine with the rocks. So as carbon dioxide was released into the atmosphere by volcanoes a long time ago, over time there was less and less of a method to take it back out of the atmosphere.
If Venus ever had life, volcanoes sterilize the entire world. Earth remains the only living world we know of. That may change. This is the gas giant Jupiter. Its moons frozen and dead. Or so we thought. Look closer, and a mystery emerges. A cloud hanging over a cold and lifeless world. On Venus, volcanoes turned an Earth-like world into a superheated hell. Finding volcanoes on an Earth-like world was no surprise. But spotting volcanoes on a moon was a shock. In March 1979, the Voyager 1 space probe gave us our first close-up view of Jupiter's tiny moon, Io. A world we once thought cold and dead.
And they saw something really weird. They saw this arc next to the moon. And it looked almost as if like there was another moon behind it.
And we scratched our heads and said, well, what could that be? Everybody knows that Io is dead, boring, uninteresting. And then people realized, oh my God, it's a volcanic eruption.
We found that it's covered with volcanoes. It is tremendously geologically active. There are volcanoes erupting all the time. And what they're erupting is a lot of sulfur, and it gets very hot. And sulfur, when it changes temperature, changes color. It can be red or orange or yellow or black. And so these pictures of the face of Io make it look like a pizza covered with different kinds of cheese and olives where the little black spots are.
Io is not dead. It's alive and kicking. It has over 400 active volcanoes. The largest, Pele, erupts from a gigantic lava lake. It reaches nearly 250 miles into space.
If we could stand on the edge of that lava lake and watch that plume shooting off into the blackness of space, that would be an incredible sight.
Pele's eruptions are so huge because Io is so small. There's nothing to hold the lava back, virtually no atmosphere, and very little gravity. These vast eruptions make Earth volcanoes look like firecrackers. How can such a tiny moon be so volcanic? The answer is Jupiter. Just as the moon raises tides in Earth's oceans, Jupiter raises tides on Io, tides of solid rock. Io's orbit around Jupiter is not a circle. Sometimes it's closer, sometimes farther away. Jupiter gives Io a gravitational pounding.
And so Jupiter's gravity pulls on it a little bit harder and a little bit weaker. And what happens is the moon stretches like this. It's called a tidal force, and it doesn't stretch this much, it's only a little bit. But in fact, it's enough to heat it up.
It's just friction. It's the same way when you rub your hands together really fast, they begin to feel warm. Friction creates heat.
Jupiter's gravity stretches and squeezes Io. In every 2-day orbit, the ground rises and falls by nearly 300 feet. This pummeling generates intense heat and gigantic pressure.
Wherever there's a weak part in the crust, the lava rushes out. So the volcanism is on a planetary scale. Unlike here on Earth, where there are certain bits that are active around the plates or in weak spots, this is an entire moon that's one active hotspot.
Thanks to the incredible power of gravity, Io is the most volcanically active world in the solar system.
The volcanism on Io taught us something new. It taught us that internal sources of energy can drive volcanism in a way that's different from that on Earth.
In outer space, tidal forces, the differential squeezing of the moons of a gas giant, can also create volcanic activity. That was a game changer.
Io is a lava world, superheated and violent. It's hard to imagine anything surviving there. Yet the volcanic principle here is the same as on Earth. Pressurized, superheated magma below the surface blasts through fissures in the crust. But not all volcanoes need magma. They don't even need to be hot. Travel out past Jupiter into the outer solar system, and it gets cold, really cold. The distant moon Triton is so cold that much of its tenuous atmosphere can freeze solid. Yet there are volcanoes here. Volcanoes that may hold the secret of alien life. We think of volcanoes as mountains of solid rock. Deep beneath, rock is so hot and pressurized that it bursts violently out as lava. But not all volcanoes work this way. There are volcanoes on other worlds that don't use molten rock at all. Right at the frontiers of the Sun's planetary system, Triton orbits the ice giant Neptune. 2.5 billion miles from the Sun, the temperature is a frigid 390 degrees below zero. When NASA's Voyager probe flew past, it revealed a world covered mostly with frozen nitrogen ice. But the probe found something else.
When Voyager flew by, it saw these black smudges, and all of the smudges were going in one direction, almost as if there was a wind blowing dark material, dust, in one direction.
Signs of activity on a world so cold it freezes nitrogen. Volcanoes at almost 400 degrees below zero. Forget molten rock. Triton spews out a mixture of nitrogen and moon dust.
And the geyser not only has liquid nitrogen, which is in a fluid form, but also sort of dusty stuff that's lighter, that can even go farther in the weak winds. So you have this wonderful sort of double plume of an icy area and then a darker, smudgy area, basically made of dust, like moon dust.
Triton's surface is nitrogen ice. Underneath, there are lakes of liquid nitrogen. How? Scientists believe it's because nitrogen ice lets light in, but doesn't let heat out.
There's almost a bit of a greenhouse effect going on Triton, that there's a layer of nitrogen ice that's transparent. And just like a greenhouse here on Earth, when you have glass, light can pass through it, but then the heat is trapped by the glass.
The sun shines through the surface and warms the nitrogen beneath. Just a few degrees is all it takes to turn nitrogen ice into gas.
A temperature gradient, a change in that temperature, that's what's important. And that's enough to melt the nitrogen underneath the surface on Triton and have it burst through as a geyser.
This is a cryovolcano, so cold that the material it erupts would freeze water as hard as rock. The solar system is more active than we ever imagined. We have found weird eruptions on many planets and moons. But so far, the only world where volcanoes are linked to life is ours. Or so we thought. This is Europa. It orbits Jupiter nearly 500 million miles from the Sun, a frozen 2,000-mile wide rock-hard ball of ice. From a distance, its surface looks smooth. Up close, it's a different story. Jupiter's enormous gravity gives Europa a pounding, just like its neighbor Io. The surface heaves and flexes, creating ridges and deep crevices.
When we first got close-up images of Jupiter's moon Europa, they looked a little familiar. And it turns out it looks like ice flows that you see when you fly over the Arctic. And it turns out it's the same thing. Europa has a several-mile thick shell of ice on its surface, and beneath that is a global liquid ocean.
Magnetic readings suggest Europa has an ocean that's a staggering 60 miles deep. Jupiter's gravitational pounding heats the rocky core and melts the ice above.
It's not unreasonable to think that as the core is being stretched by tides and heated up, possibly even molten, there's some boundary between a hot core and a liquid water ocean.
On Earth, underwater eruptions are surrounded by life. The same could happen on Europa. Here, the darkness is total. The pressure, a crushing 2,000 Earth atmospheres. A brutal world, but perhaps a cradle for life.
If life got off the ground here on Earth, why not on Europa? All the ingredients are there: an energy source, volcanic activity, a universal solvent, liquid water, a rich hydrocarbon chemistry. We have this mixing bowl of ingredients that happened on the Earth 3.5 billion years ago, and we have similar conditions on Europa. So some people are saying, if it happened here, why not there?
Life on Europa would be hard, but not impossible. On Earth, there is life at every extreme. Searing heat, crushing pressure, total darkness. Alien life on Europa might look surprisingly similar.
If life exists under the ice cover of Europa, they would be aquatic, but without eyes, because there's no light to speak of. They would probably use sonar in order to make sense of their surroundings. Organisms that literally feed off the energy from the volcano.
On Europa, volcanoes could be the source of new life. It's even possible that Europa is normal, that this is how worlds with life generally are. Earth could be the exception.
Think of it, Europa could be a template for billions of moons out there that have liquid oceans on them. So all of a sudden, our horizons have expanded several billion times by looking at the moons of Jupiter. What a shock.
Our solar system alone has over 170 moons. Multiply that across the universe, and that's a lot of places where life might take hold. All it takes is liquid water and a source of energy. Potentially, volcanoes provide both. And they are everywhere. This is Saturn, twice as far from the Sun as Jupiter. Yet it too has volcanic moons. And just like Jupiter's Europa, these moons could harbor life. This is one of the strangest worlds in our solar system, Saturn. A ring system 600,000 miles wide, an amazing 62 moons, and one with a secret.
Enceladus is one of Saturn's smaller, more distant moons, and it's been known for a long time that it's covered in ice because it's very bright, very reflective. But when the Cassini spacecraft went there, it discovered something amazing.
The Cassini probe revealed something incredible, not on the planet itself, but on Enceladus. Backlit by the sun, a gigantic plume bursts out into space, a sure sign of volcanic activity. It was an amazing discovery, and it helped answer a question that has puzzled scientists for decades: the mystery of Saturn's E-ring. Saturn's outermost ring is vast, almost 200,000 miles across, and it shouldn't exist. The ice particles that make up most of the ring are too far from Saturn to stay in orbit. They constantly drift away into space. Something replenishes the ring: the ice volcanoes of Enceladus.
Those plumes that are ejected from Enceladus' south pole, it turns out that those are going into space, and they're not just going away. They're feeding a ring around Saturn, the E-ring. So this little moon is giving something back to its parent planet.
Water blasts from Enceladus's volcanoes, hits the vacuum of space, and instantly freezes into tiny ice crystals, creating the vast E-ring. One mystery solved. Another replaces it. What creates the volcanic plumes? Cassini's cameras zoom in on the moon's south pole and capture these huge chasms scarring the surface.
There are these wonderfully huge cracks at the south pole of Enceladus. And as Enceladus goes around Saturn, these cracks open and shut as the tides go by. Now, these cracks are huge. They're hundreds of miles long. And when they begin to open, you would have this big crevasse opening at maybe 100 miles an hour down the length of that. It'd be incredibly spectacular.
Huge gravitational forces crack the surface open and closed at enormous speeds. Like Europa and Io's orbits round Jupiter, Enceladus's orbit round Saturn is elliptical. This helps generate the heat to melt ice and create oceans of water beneath the surface.
The conditions of the water underneath Enceladus' surface are absolutely perfect for life. It's the right temperature, it'd be a good pressure for life. Liquid water would be just like seawater here on Earth. And the chemistry of the water we see shooting out of these vents suggests that it is very similar. There's salt, there's organic material in it as well. So we have identified a place in the solar system where there very well may be life right now.
Cassini has detected complex carbon molecules in the ice plumes. Combined with liquid water, these suggest that just maybe life could survive deep within this enigmatic moon. Enceladus may not be alone. Another of Saturn's moons might also harbor life. Titan, one of the largest moons in our solar system. The only moon with a thick atmosphere. A frozen world, ice as hard as rock, lakes of liquid methane. Yet here too, we might find evidence of volcanoes and the tantalizing prospect of alien life. A raging inferno on the surface of Io. Eruptions of ice and nitrogen on Triton. Volcanoes are one of the most destructive forces in our universe. But out of annihilation comes the possibility of life. Even here, on Saturn's mysterious moon, Titan. It's 3,000 miles across, larger than the planet Mercury. It's the only moon in our solar system with a thick atmosphere. There is weather here, storms, winds, rain, even lakes, all so cold that liquid methane takes the place of water. and it's loaded with chemicals that life needs to survive.
Titan has turned out to be absolutely one of the most interesting places in the solar system. It's an active world. It's the only moon with a thick atmosphere, an atmosphere very much like Earth because it's mostly nitrogen, and it turns out an atmosphere loaded with organic molecules.
Methane gas high in Titan's atmosphere reacts with sunlight and creates the kind of chemicals life depends on. But if sunlight converts methane into organics continuously, why doesn't the methane run out?
The atmosphere is full of methane, and yet we know methane is being destroyed by sunlight on a short time scale, so it shouldn't be there. There needs to be a source of methane.
Something on Titan pumps out a continuous supply of methane. Cassini has detected what looks like a crater. Its interior is as deep as the Grand Canyon. Infrared cameras reveal different types of materials surrounding the crater. Scientists believe the green areas could be volcanic, perhaps plains of lava ejected from Titan's interior. If it exists, lava, Titan style, is a super chilled, icy slush. But compared to the rest of Titan, even ice slush is scalding hot.
On Titan, the hot liquids spewing from volcanoes might be ammonia or water. Normally those are frozen solid on the surface, but if they're heated beneath the surface somehow, they could erupt out.
On Titan, what comes out of volcanoes is methane and ethane. And that's probably the reason why we have this very thick cloud cover, this orange haze around Titan. This haze probably came from outgassing from the volcanoes of Titan.
Even for volcanoes on a world as cold as Titan, you need heat. That's what turns ice into liquid and generates eruptions. On Titan, that heat has two sources. Radioactive materials warm the interior. And Saturn's huge gravity massages the moon, just like Enceladus. These two forces generate enough heat to turn ice into water and liquid methane to gas.
We think of volcanoes as being hot and ice is cold, and yet if you're out on Titan, where you're a billion miles from the sun and it's quite cold, then those flows of just barely above freezing water, ammonia, ice, they might be the hottest things around. So hot is a relative term depending on where in the solar system you are.
Could volcanoes on Titan give life a chance to survive here? Life as we know it needs an atmosphere, a solid surface, liquid water, and the heat to drive chemical reactions. On Titan, volcanoes could provide them all.
If you have a volcano on Titan, you'll have heat added to that. And all of a sudden, you'll have liquid water surrounded by organic material. I mean, literally anything you need for the start of life.
If life does exist on Titan, it would be truly alien. It would breathe hydrogen in place of oxygen, perhaps swimming through lakes of liquid methane at 300 degrees below zero.
Perhaps there are oceans of ethane. Perhaps there are tide pools and perhaps volcanic activity and hydrothermal activity. Perhaps there are hot springs. Perhaps volcanic heat could generate enough to get life off the ground in Titan. That's a speculation, but it can't be ruled out.
But we may not need to travel this far to find signs of life. We may find it on a volcanic world much closer to home. The Red Planet, Mars. volcanoes are everywhere, across the solar system. Worlds like Io, Titan, and Triton are complex, dynamic, and violent. Once, we thought that Earth was the only planet with volcanoes and with life. Now we find volcanoes everywhere, but we have yet to find alien life.
Volcanoes embody the sheer power of creation and destruction, and they go hand in hand. It is literally true that if there weren't volcanoes here, we would not be here either. In the cauldrons of volcanoes is the origin of life.
Volcanoes create new landscapes, seed the atmosphere with complex chemicals, replace the old with the new. If volcanoes are bound up with the processes of life, then where is the life on other worlds? Perhaps the answer originates in deep time when the solar system was young. On a young planet, much like our own. This is Mars. 3 billion years ago, it had active volcanoes. One still remains the largest volcano in the solar system. The cliffs leading to it are over 6 miles high. Mount Everest would sit comfortably in their shadow. And those are just the foothills. This is the awe-inspiring Olympus Mons. It covers an area the size of Arizona. Its crater alone is 53 miles wide. A Goliath like this takes millions of years to build, time that volcanoes here on Earth never get. On Earth, the crust is always moving. Deep below, a single hotspot pushes magma through the surface, building a new volcanic island. But while the hotspot stays still, the surface is moving. The new island moves away from the hotspot, and a new volcanic island takes its place. Mars is different. The crust is locked solid.
On Mars, there's just none of that tectonic activity. The crust is one big solid plate, and so if there's a hot spot, it just sits there and builds and builds and builds, and you get a bigger and bigger and bigger volcano. And that's why Olympus Mons is so huge.
Olympus Mons today is a frozen relic of a distant, warmer past. Mars's shrunken atmosphere means that Olympus now reaches almost into space. A true colossus, an extinct volcano on a dying world. But Mars's ancient volcanic terrain could, one day, harbor life again. The evidence is right here on Earth. On Hawaii, volcanoes have created mysterious tunnels called lava tubes. Channels left behind when torrents of molten rock surge into the sea. But some are now empty, and that offers us an opportunity.
Lava tubes are formed when you have an underground river of hot basaltic lava, 2,000-degree magma, molten rock. And picture it like a frozen river of water with the ice crust forming on the top. It's the same thing, only here the crust is solid rock, and the river keeps flowing underneath and makes this cave, this lava tube.
Extraordinary recent images suggest Mars's volcanoes also may have created lava tubes.
Any planet with basaltic volcanism, any rocky planet, will probably have lava tubes. And now we found a couple of them on Mars, in places where there are skylights, places where the roof has collapsed and you can see from orbit right into those lava tubes.
If some tubes have collapsed, perhaps many others are still intact. The ancient relics of Mars's volcanic past. Now, after lying dormant for perhaps millions of years, these lava tubes could bring life back to the red planet. That life will be us.
One of the challenges of living on Mars for future humans will be the radiation environment, and in particular, when there are solar storms, the cosmic rays coming in can be deadly. And having a storm shelter under some large mass of rock is really the best way to protect yourself from cosmic rays.
The tubes and caves of Mars's extinct volcanoes might one day make a perfect home, holding in air, shielding us from deadly radiation. A long-dead volcano could help fill a world with new life. On some planets, storms are impossible. Superheated Mercury is too small and too close to our sun to have a significant atmosphere. And no atmosphere means no storms. But move out away from the sun, and we find worlds with turbulent, chaotic atmospheres. They can spawn some of the most awe-inspiring megastorms in our solar system. This is Venus, a planet completely shrouded with clouds. Winds rip around the upper atmosphere at over 300 miles per hour.
About 35 miles above the surface, the winds are whipping around in a ferocious pattern that basically carries the cloud features around the entire planet every 4 days.
Venus is closer to the sun than Earth, and it's heat from the sun that drives the wind.
The circulation pattern of Venus's clouds is actually quite simple. There's a warm side of Venus and a cold side. And as air warms up and rises on the day side of Venus, it spreads around to the night side. So there's this continuous current. It's actually quite a lot simpler than the atmospheric circulation on Earth.
Venus's winds circulate faster than the fastest hurricane on Earth. But they look very similar. The Venus Express probe captured these remarkable images of the planet's south pole.
One of the great mysteries of Venus, which actually had jaws dropping in the halls of many astronomy departments, is the fact that we have hurricanes at the poles of Venus, especially in the southern hemisphere, that have two eyes. Not one eye, but two eyes. Now, we've never seen this before on such a planetary scale.
Venus's double-eyed vortex is 1,800 miles wide. Two hurricanes whirl around each other.
If you could descend into the vortex of Venus, something I would love to do, at least with a remote machine, I think you would see some kind of a fantastic wall of cloud and this sort of twisting form spinning around you at ferocious speeds. It would be quite a sight.
It's a mystery how deep this raging, spinning vortex goes. But maybe this megastorm Eye descends to the planet's surface. Down here, permanent twilight bathes a volcanic landscape, and the atmosphere's colossal weight creates immense pressure.
And the atmospheric pressure on Venus is about 100 times that of the Earth. Think of taking a car, squeezing it down to about a square inch and putting it on every square inch of your skin. You would be flattened within a fraction of a second because of all that pressure.
Venus's dense atmosphere creates one of the strangest megastorms imaginable. 4 miles per hour winds with the force of a hurricane.
The winds on the surface of Venus are actually very slow because Venus has a very slow rotation rate. It takes Venus about 8 months to turn once around with respect to the sun.
The crushing atmospheric pressure rams gas molecules together so tightly that they feel more like a liquid. A gentle 4-mile-an-hour breeze packs a brutal punch. It's like a hurricane in slow motion.
Winds on Venus are totally unlike anything we see on the planet Earth. You would almost feel like a molasses effect. It'd be quite difficult to simply walk and run right through the wind.
Venus's surface is so hostile that life is impossible here. But the upper atmosphere's faster winds hold an extraordinary possibility.
Well, I harbor this, I don't know if I would call it a hypothesis or a scientific fantasy, but I do think it's plausible that there could be some kind of life living in the clouds of Venus. There are certainly energy sources, there's sunlight, and there are certainly nutrients. There's carbon, there's hydrogen, there's oxygen. All the stuff we think of that you need to make life exists in the clouds of Venus.
Earth's upper atmosphere is full of life. Microscopic bacteria drifting on the wind. Could Venus be the same? Perhaps one day we'll send a probe to find out. Leave Venus behind, and the next planet is Earth. Here, too, the weather gets extreme. We are bombarded by tornadoes, hurricanes, and these dust storms. On Earth, they're localized. But on the next planet out, they engulf an entire world. Over 100 years ago, astronomers thought they had found life on Mars. A dark wave spread from the pole towards the equator. They thought it was springtime vegetation spreading across the planet. They were right about the season.
Mars tilts at roughly 23 degrees like the Earth, so you would have summer, fall, winter, spring like the seasons.
Seasons bring weather. The shadow astronomers saw was actually dark rock uncovered by a violent dust storm. It's all because of the way the planet tilts. The Earth takes 1 year to orbit the Sun. In January, the northern hemisphere leans away from the Sun, and we get our winter. In June, it leans inwards, our summer.
Mars has gigantic planetary dust storms, the like of which we've never seen here on the planet Earth.
Mars has around the same tilt as Earth, and springtime means storms. The Martian surface vanishes under a cloud of raging dust particles. On Earth, we get dust storms too. They can be devastating, swallowing entire cities. July 5th, 2011, Arizona. An unstoppable 5,000-foot-high wall of dust smashes into Phoenix. Day turns to night. Thousands of tons of dust settle over the city. But the disaster stays in one place. Mars's dust storms can engulf the entire planet.
On Mars, when dust gets kicked up once, it lands, it can get kicked up again and again. The dust is reusable. On the Earth, when dust gets kicked up and then finally settles out, it's probably going to settle out into the ocean, where it's gone for good.
There's nowhere on Mars where there isn't ready dust and sand to add to that storm. So these storm systems can kick up and last weeks or even months.
Mars's incredibly dry atmosphere contributes to the storm's size and power.
In the case of the Earth, dust that gets up into the atmosphere is rapidly washed out by the rain and gets into the ocean. In the case of Mars, there's no comparable rain to wash the dust out. So once the dust gets into the atmosphere, it just sits there until the particles by themselves are able to slowly settle out.
A lack of rain allows Mars's dust storms to cover the planet. But dust storms on Mars can be equally spectacular on a much smaller scale. NASA rovers captured these extraordinary images. Dust devils sucking up fine, dry iron oxide dust. The biggest dust devils can reach 6 miles into the sky. They pump fine particles high into Mars's atmosphere, creating a haze of dust that may help control the planet's dry climate and lead to a planet-wide megastorm. Even on Mars, dust storms this big are rare. Astronomers have detected just 10 in the last 100 years. What the ancient astronomers mistook for life was a megastorm. But even a planet-covering dust storm is dwarfed by the weather on the next planet out from our sun. This is the giant of our solar system, Jupiter. Jupiter is gigantic. It's 2.5 times more massive than all the other planets in the solar system added together. It's also home to gigantic megastorms. Jupiter's high-speed rotation drives vast bands of counter-rotating clouds. Colossal storms build along the boundaries. And this is the biggest of them all. The oldest storm in the solar system. 15,000 miles across and over 300 years old. The Great Red Spot. Around the edges, turbulent winds rage at over 300 miles per hour.
The Great Red Spot is a giant vortex, meaning that in the case of the red spot, it has a high pressure center with winds that swirl around the outer edge. So in that sense, the Great Red Spot is a little bit like a hurricane.
A hurricane with a difference. On Earth, hurricanes feed off heat from the ocean. When they hit land, they start to die. So on average, they last only about a week.
Jupiter does not have land. Jupiter is a completely gaseous planet, and the friction there is very weak. And so a vortex, like the Great Red Spot, can last indefinitely. There's nothing to slow it down.
To keep going, all the red spot needs is a power source. On Earth, ultimately that's heat from the sun. But Jupiter's 5 times farther from the sun than us. Heat from the sun is not enough to drive the red spot. Instead, Jupiter has an internal power source, its own immense gravity. In 1995, NASA launched a probe straight toward the giant planet's heart. It plunged into Jupiter's upper atmosphere at over 106,000 miles per hour. As it fell, the planet's crushing gravity ratcheted up the pressure. 10, 15, 20 times what we feel on Earth. Winds gusted to over 400 miles per hour. The probe gave out just 100 miles in, crushed by pressure and fried by the incredible heat the pressure generated. Had the probe made it deeper, it would have reached a vast silvery ocean. Intense pressures here turn hydrogen gas into a churning metallic liquid, superheated to over 40,000 degrees Fahrenheit. Jupiter's interior pumps out about twice as much energy as the surface gets from the sun. This is Jupiter's power source, the heat that drives its massive megastorms.
All of the convection, all of the heat comes from the hot, dense interior of the planet itself. So the bands of clouds that you see that are even counter-rotating, going in different directions, those are all driven by the internal heat of Jupiter itself.
Jupiter's internal heat drives its violent megastorms. But the giant planet may hold clues to an even deeper mystery. Could life exist on other worlds? NASA's Cassini probe studied Jupiter as it flew past en route to Saturn. It made an extraordinary discovery. Strange white clouds just north of the Great Red Spot. Clouds just like the clouds on Earth. Droplets of liquid water. Could Jupiter have the ingredients for life?
The question of life on the giant planets is an interesting one. You have many of the ingredients for life. You have sunlight coming in, there's liquid water, at least in the form of cloud droplets. On the other hand, if life can easily exist in clouds, you might expect that bacteria and algae would populate the clouds on Earth and the clouds would be green. We don't see that on the Earth. We do see microbes at many altitudes throughout the Earth's atmosphere, but they seem to largely be blown off of the surface.
It's likely that life on Earth began on a solid surface. But could life evolve without one?
There's no surface on Jupiter, and so that makes it difficult for organisms to have a constant source of water. So if you imagine yourself being a little bacterium inside a cloud droplet, you're going to be in deep trouble when that cloud droplet evaporates.
Whether life exists in Jupiter's clouds or not, gas giants like Jupiter and its neighbor Saturn have all the right ingredients: water, heat, and one other vital element: a spark. Lightning on an unimaginable scale. These haunting images are from NASA's Cassini probe. Its mission: to explore one of the solar system's most awe-inspiring planets, Saturn. The probe reveals Saturn's rings, moons, and the planet itself in near-perfect detail. Chaotic bands of cloud race around Saturn at more than 1,000 miles per hour. Finding storms here was no surprise. It's a planet of storms. But this was astonishing. A bolt of lightning, a gigantic thunderstorm on an alien world. Lightning creates some of the most spectacular weather on Earth. Electrical tension builds between the top and bottom of a vast 55,000 feet high storm cloud. A maelstrom of water vapor, rain, and ice. Tiny ice crystals drive up past hailstones falling down. As they rub past each other, it builds up a charge. When the strain gets too great, you get an electric spark. On Earth, the average lightning storm stretches 15 miles. On Saturn, they can reach around the whole planet.
There are examples of lightning storms on Jupiter and Saturn where the anvil cloud, in other words, the big cloud at the top of the storm, starts small and grows to be 20,000 kilometers long. That's the size of the Earth.
On Saturn, we registered one lightning storm that was 10,000 times greater than any lightning storm found on the planet Earth.
Lightning is hotter than the surface of the sun. The atmosphere literally explodes. The sound we call thunder. On Earth, it's the sound of new life.
Lightning seems scary and destructive, but actually it's very productive for life on Earth. And the reason why is because of its influence on atmospheric chemistry.
Every bolt literally burns the air.
When you have a lightning discharge, you get this very high temperature, very energetic plasma, and that breaks up the nitrogen molecules in the atmosphere, frees up those nitrogen atoms to enter into other kinds of molecules, and those nitrates formed by lightning allow nitrogen to go into the soil as basically fertilizer, enter into plants, enter into the life cycle. So it's the lightning that frees up nitrogen atoms in the service of life on Earth.
Earth experiences 8 million lightning bolts every day, helping life evolve and colonize the planet. But for Saturn, lightning alone may not be enough. There's nowhere for alien life to live. One place in our solar system may solve that problem. Saturn's moon, Titan. It has an atmosphere. It has lakes of liquid methane. And its own bizarre brand of megastorm. Saturn is almost 900 million miles from the Sun. This far out, orbiting the Sun takes time. Saturn's year is nearly 30 Earth years long. Right now it's spring, and things are heating up.
Moving into the summer cycle of Saturn. So the atmosphere is slightly heating up, even as distant as Saturn is from the Sun. We've got a little more energy, and we're seeing the most spectacular storms we've ever observed on Saturn.
After years of frozen silence, Saturn is coming alive. Scientists have waited nearly 15 years for the Sun to light up its North Pole, to reveal extraordinary details about one of the strangest megastorms in the solar system. Saturn's unique hexagon storm.
A hexagonal pattern, how can that be? In Mother Nature, we have jagged objects. We don't have geometric figures arranged precisely, especially at a gigantic planetary scale. However, there's some theories. If I take a bucket of water or a bathtub and simply vibrate it, I get waves that travel. But there's another kind of wave. You have traveling waves, but then you have stationary waves. Inside a bucket of water, you can get resonances. Water pulsates like this. And you can also get them to pulsate in a circle like this to create regular patterns. These are called stationary waves, and we think that this mysterious hexagonal pattern on Saturn is a hexagonal standing wave.
The megastorm at Saturn's North Pole is a wind that travels at hurricane speed, cornering sharply 6 times as it races round the planet. The central clearing is so big, you could fit 4 Earths inside. What lies beneath its surface is a mystery. As Saturn warms from spring to summer, another world comes alive too. One of Saturn's moons, Titan, is warming up. And with the warmth come the storms.
One of the most interesting moons in our solar system is Titan. It's straight out of science fiction. It's an object with yellow skies and methane clouds that is truly remarkable.
NASA's Cassini probe reveals Titan in unprecedented detail. A thick, dense atmosphere, vast mountain ranges, lakes of liquid methane. And this, an arrow-shaped band of white methane clouds moving over its surface. When the clouds drifted over a dusty open plain, seen here as a dark patch, the dark patch of ground beneath the clouds grew larger. Scientists believe liquid methane drenched the surface. A spring rain storm, Titan style.
Rain on Titan, if it exists, would be very different from rain on the planet Earth. First of all, the gravitational field is very weak, so you would actually see raindrops falling very slowly at you. Also, the size of these droplets could be much larger. But don't get caught in a rainstorm on Titan. Those droplets are awfully cold.
Titan's methane monsoon sweeps across the moon. Weak gravity creates ultra-cold, hazelnut-sized raindrops, an alien world with truly alien weather. These slow drops have carved valleys and lakes, much like ours on Earth. A slow-motion megastorm. But fly even farther out through the solar system, and you find storms that are altogether faster. This is super-chilled Neptune. The temperature never gets above 300 degrees below zero.
Neptune is one of these giant planets. It's much larger than the Earth and has a very thick atmosphere. It's about 2 billion miles out from the sun. So you really might expect, since it's that far from the sun, it would be very cold and not have very much weather. But in fact, Neptune is very dynamic. It's got tremendous weather patterns.
Despite its incredible distance from Earth, astronomers can get close to Neptune's turbulent atmosphere. With a little help from this. The Keck Observatory. 14,000 feet up on the summit of Mauna Kea in Hawaii. It sits above Earth's clouds and pollution. The telescopes are so powerful, they could see a candle on the moon. Neptune at first appears featureless, but a closer look reveals white, high-altitude clouds in the upper atmosphere. It's a perfect opportunity to track wind speed. Measuring the time and distance the clouds take between 2 points allows scientists to clock their speed. The Keck telescope swings towards Neptune. A series of shots track the white clouds as they move around the planet.
So here we can take several photographs that show the positions of clouds apparently changing. You can measure the position at one moment to be there, and at another time, a few hours later, to be in a different place. Now, most of that change in position is due to the rotation of the planet as a whole. However, if you know the rotation rate and subtract that out, that gives you the motion of the clouds relative to the planet. That tells you the wind speed.
The results are shocking.
We're seeing wind speeds on Neptune of many hundreds of miles per hour, up to 12 or even 1,260 miles per hour for the very fastest clouds. That's really phenomenal.
Neptune has the fastest winds in the solar system.
So what's driving this? You need energy to make weather. Where's that energy coming from? And it turns out it's coming from Neptune itself. It does receive sunlight, but Neptune actually radiates away more energy, a lot more energy than it gets from the sun, which means the interior is very hot. Probably it means there's radioactive material in there, there's leftover heat from when Neptune formed 4.5 billion years ago that's very slowly leaking out. And it's that that's heating up the air and driving all of the circulation and all of this crazy weather that Neptune has.
Neptune's storms hit hard. But the search for truly extreme weather takes us out of the solar system altogether, into uncharted territory. Out here, there are storms that make even Neptune's winds look like a breeze.
Katrina was just a sneeze compared to the winds we have on Osiris.
The search for megastorms leads to alien worlds whose violence defies imagination. Space is full of stars and planets where violence and chaos reign. Astronomers scour the skies for new worlds, and the king of the planet hunters is Professor Geoff Marcy. He scans the night sky seeking new worlds around distant stars. Marcy's team has instruments so sensitive they can even predict the weather on these distant planets. This is Osiris, 150 light years from Earth. A planet from hell with matching weather. Earth is 93 million miles from the sun. It orbits the sun in 1 year. But Osiris is just 4 million miles from its star. Its year races by in just 3.5 days. When Osiris passes between us and its star, starlight briefly shines through its atmosphere, giving us a glimpse of conditions on the alien world.
And they waited until the planet was in front of the star. At that moment, some of the starlight passed through the atmosphere of the planet. They were able to do essentially a chemical assay, a chemical assessment of the composition of this atmosphere.
Osiris gets blasted by the intense heat of its star. Temperatures top 2,000 degrees.
Now, what that means is that the environment on that planet is, well, hideous for life as we know it. But even more, the intense heat causes the gases to expand, and they have no place to go but the backside of the planet.
Osiris is tidally locked. The same side of the planet always faces the star. The other looks out into space. The temperature difference is immense. Superheated atmosphere roars from the bright side of the planet to the dark at nearly 6 times the speed of sound.
In fact, the winds will be something like 2,000 or 3,000 miles per hour. Enormous speeds of these winds, 10 times, 20 times faster wind speeds than the strongest hurricanes. Katrina was just a sneeze compared to the winds we have on Osiris.
Osiris is a brutal world. Too hot and too violent for any kind of life we could imagine. But there are even larger megastorms, storms on the scale of whole galaxies. And these vast storms may be the reason any of us are here. The Hubble Space Telescope captured this stunning image of the galaxy NGC 3079. At its center, a superwind, a storm on a truly cosmic scale. It was triggered by an explosion from a forming star. This raging galactic storm is about 3,000 light years wide. It has already raged for around 1 million years. Filaments of 20 million degree gas tower above the spiral galaxy. This cosmic megastorm wreaks havoc within its host galaxy.
We see bubbles and jets and formations of gas falling into the galaxy, colliding with galactic dust.
The gas from the galactic megastorm smashes into gas and dust at the heart of the galaxy and compresses it into a swirling mass of matter. Gravity takes over. The compressed clouds of gas and dust get tighter and tighter. The center gets hotter and hotter. Finally, it ignites. Powerful winds from the new star blast into space. The whole cycle begins over again, and a new galactic megastorm is born. Around the fledgling stars, dust and rock come together. The birth of new worlds with rocky surfaces where life could begin.
And perhaps the formation of life itself may be determined by how these gases swirl and create supergalactic storms. And if you have galactic winds churning away, then that would help to distribute the elements necessary for life throughout the galaxy. So galactic storms may in some sense be one clue to the formation of life itself.
Galactic megastorms rage for millions of years. Billions of years ago, they may have created new homes for life in our Milky Way galaxy. On every scale, storms are not just a force of destruction. They are linked to creation itself. The search for life on other worlds is also the search for storms.
When you disrupt the status quo, you open all kinds of possibilities for things to reassemble in different ways. So chaos or disruption is actually an important factor in the development of complex systems like life.
A planet that might have changes of seasons, volcanism, intense storms, some environmental factors that you might think could be damaging to life, in the long run makes life stronger.
Look out at the cosmos. Billions of galaxies. Trillions upon trillions of stars. And one profound question: is anyone else out there?
We want to find another Earth. Is there a pale blue dot orbiting some star out there in the galaxy?
The search is on for worlds that could harbor life.
We're searching for our own vision of ourselves out there in space. We're searching for our heaven.
We've already discovered more than 700 planets beyond our solar system. And yet these exoplanets look nothing like our own.
Boy, were we wrong. All these solar systems that we're seeing in outer space, we find that they don't look like our solar system at all. We are the oddball. We're the freaks.
These are nightmare worlds. And the cosmos is full of them.
We're finding all different flavors of hell, all these different ways that planets can go wrong. So that's where we are right now, searching for heaven, finding hell.
These are worlds where life couldn't possibly survive. Could we really be alone? A cosmic fluke in a universe hostile to life. we may soon have the answer.
Now we have discovered hundreds of exoplanets in outer space at the rate of over 1 exoplanet a week.
In a few years, that will probably be thousands. And in the end, there could be millions or even billions of these things waiting for us to discover them.
How could all of them be planets from hell? The quest for answers starts here, 63 light years from Earth. We've discovered a planet. It's even larger than Jupiter. And it has a serious problem. Its orbit is incredibly tight. It's closer to its star than Mercury is to our sun. And 30 times closer in than the Earth. The result is a superheated hell. But there's another reason why nothing could survive here. And that's the ferocious wind. The surface is battered by a never-ending storm. We can't see these winds with our telescopes. But we know the superstorm exists. Because of this. NASA's Spitzer Space Telescope. Spitzer can see things that we can't. It doesn't use visible light. Instead, it sees in infrared. It's a part of the light spectrum we don't see with our eyes. Infrared is heat.
One advantage of studying the universe in the infrared is it gives us this opportunity to see the light coming from planets around other stars. When you try to look at the light of a planet next to the light of a star, the star is hundreds of thousands of times brighter than that planet, which renders the planet very, very faint. But if we push into the infrared part of the spectrum, the internal heat of the planet, just as my internal heat, causes the planet to glow. Now it's observable and measurable.
Spitzer gives us something completely new. The very first weather map of a planet beyond our solar system. This simple image is a technological triumph. The colors represent temperature differences. But the map also proves the planet has hellish winds. That's because the hotspot isn't where it should be. One side of the planet permanently faces the star, so its center should be the hottest point on the planet. It isn't. Something pushes the planet's hotspot to the side. And that takes incredible force. Only a non-stop 6,000-mile-an-hour hurricane could be this powerful. "20 times stronger than the strongest winds on Earth. 8 times the speed of sound. A small shift on a weather map. Evidence of supersonic winds raging on an alien planet. Truly, a planet from hell. We're finding new planets at a staggering rate, an average of 1 a week. Each one could be an Earth-like heaven. But the more we explore them, the more hellish worlds we find. And some are so nightmarishly hot that they're more than uninhabitable. They shouldn't even exist. This Jupiter-sized gas planet is 256 light-years from Earth. In infrared, it shines like a star. Thousands of times brighter than Venus, the hottest planet in our solar system. It's a blistering 3,700 degrees. It's nearly impossible for a planet to get this hot. Its hellish temperature provides a clue to its appearance. Only an absolutely black object could absorb enough light from its star to reach such scorching temperatures.
If you were coming up on the night side away from the star, you would just see this blackness in front of you. Very little radiation, very little light. It would almost just look like the stars were avoiding a part of the sky.
Just as black pavement absorbs sunlight and heats up on a sunny day, the black planet roasts beside its star. We don't understand its atmospheric chemistry. There's nothing on Earth that can absorb so much light. The planet's only color comes from a scorching hotspot.
As you flew around to the day side, things would begin to glow red hot. There'd be a huge swirling storm, all red and glowing. What a hellish world.
Deep inside, clouds of titanium oxide swirl around a solid heart, 100 times heavier than Earth. Darkness visible, another world from hell. But some planets are even bigger, seemingly impossible puzzles.
Here's a mystery. Every astronomy textbook says that gigantic Jupiter-sized planets form way out in outer space where it's really cold. So why is a Jupiter-sized planet, what's it doing inside the orbit of Mercury?
Jupiter-type planets can only form far from their parent stars, out in the cold of space. A gas giant orbiting this close means these monsters can move. This is WASP 12b, a scorching vision of hell. It's so close to its star that its orbit lasts just 1 Earth day.
This world is so hot, it's over 4,000 degrees Fahrenheit. This is just crazy hot.
WASP 12b is one of the hottest planets in our galaxy.
We've never seen anything like this before. This certainly is one of the most violent environments in the universe.
WASP 12b is only 2 million miles from its star. Searing heat puffs up its atmosphere, giving it the density of styrofoam. In a big enough bathtub, it would float.
We actually think it's so close to its star that the gravity, the tidal effect of gravity, warps it into almost an egg shape. It's not even round, it's oblong.
Thousands of miles beneath the puffed-up atmosphere lies a solid core. It's rich in carbon, and the pressures are extreme. There could be mountains of diamond and graphite, and seas of liquid tar. But WASP-12b won't last long. It orbits so closely that its star is literally tearing it apart, ripping away nearly 190 quadrillion tons of gas a year. "10 million years from now, WASP-12b will vanish. The question is, how did it get so close in the first place? This is the birth of a solar system. In the center, a new star. Around it swirls a disk of microscopic dust grains. These are planets in the making.
Dust grains collide, and every time they collide, they merge, and so they get bigger and bigger, and so they sort of grow like the dust bunnies under your bed. And you have 100,000 years or 1,000,000 years to make a very big dust bunny, and they get bigger and bigger and bigger.
Trillions of miles from the star, it's cold enough for ice to form. Ice picks up dust and gas. These gaseous clumps grow bigger and bigger over millions of years. Eventually, they become gas giants. In our solar system, the gas giants, Jupiter, Saturn, Neptune, and Uranus, all formed this way. In the distant orbits we still see today. So how did WASP-12b end up so searingly close to its star? The answer? Gravity. This planet is huge, 40% more massive than Jupiter. Its immense gravity disturbs the dust disk it formed from, creating turbulence.
And so the planet creates waves in the disk, sort of density waves. And you can sort of think of them as like waves on an ocean.
The gas giant becomes a galactic surfer. Over hundreds of thousands of years, the planet rides the waves inward toward the star.
As the planet gets closer and closer to the star, it starts to feel the radiation from the star more and more, and so it heats up.
Surfing millions of miles from the cold outer reaches of the star system into the tight, scorching orbit we see today. An ice-cold world becomes a planet from hell.
Nobody had any real clue that you could form a planet 1 billion miles out from a star. It somehow moved in. That is incredible, but that's really the only explanation of how these planets got so close to their stars in the first place.
WASP-12b is bizarre, but it isn't alone. we've found many of these super hot, super close giants. We call them hot Jupiters. Battered by supersonic winds, blacker than night, hotter than hell. But these hot Jupiters all have one thing in common. There's no life here.
So these planets are just about as different from the Earth as you can possibly imagine.
In fact, we've now found over 100 of these things, rendering them so common that the question really emerges, which ones are the weirdos, them or us?
This planetary roller coaster has consequences. As they spiral inward, hot Jupiters cause chaos. They create a whole new class of planets from hell. Orphan worlds, flung away from their star into the emptiness of interstellar space. Planets orbit stars. Between the stars is a vast sea of darkness.
We've always thought of space as being empty. That would be considered its defining characteristic. That's why we call it space.
But when planet hunters switched from gazing at stars to staring deep into space, they made an amazing discovery. Out of the darkness, between the stars, planets began to appear. First, one dark gas giant. Then several more. Eventually, 10 dark, starless planets emerged from the shadows of space.
I often wonder what it would be like to be on one of these rogue planets in between stars. The night sky would be perfectly black. It'd be festooned with stars. It'd be beautiful.
But if you were at one of these planets, you would be in a world of perpetual night. There would be no sunrise or sunset. There would be no warmth of the sun.
These planets formed around a star, but now they roam the darkness of interstellar space. Their journey here was violent, each one forced from its home orbit by the gravity of a hot Jupiter.
A Jupiter-sized planet is an 800-pound gorilla. Where does it sit? Anywhere it wants to.
Hot Jupiters are killers. As they surf in toward their star, their immense gravity disrupts the system. Hurling planets from their orbital paths.
It flings into outer space any small planet. So any planet unfortunate enough to be orbiting close to the mother star would be flung into outer space with a passing Jupiter.
These planets will never again feel the heat or see the light of a star. All the rogue planets we've found so far are gas giants, but perhaps there are smaller, rocky worlds too. Worlds that were once like Earth.
The large Jupiter-like planets are just easier to see, but there's no reason to assume there also aren't smaller orphan planets. Maybe as a Jupiter planet moves in toward the star and plays ping pong with the planets, even something like Earth could have gotten kicked out. Then you would have this cold, frozen little world, just streaking between the stars, dark and lonely.
These planets are victims of a violent gravitational battle. Frozen, orphaned Earth twins.
There may be hundreds of billions with a B of these planets roaming the galaxy. Now, there are only a couple of 100 billion stars in the galaxy, so that means these rogue planets may actually outnumber stars.
Right now, we find an average of at least one new exoplanet a week. As our technology improves, we'll see smaller and smaller planets orbiting stars, worlds with a solid surface like our own. But the first rocky planets we've found are nothing like Earth. These planets have been to hell and back. We have found hundreds of alien worlds. And now for the first time, we're finding small planets made of rock, just like Earth. Planets this size are potential homes for life. But instead we find more planets from hell. Weird, nightmarish, and uninhabitable. This is Coro 7b. A world of violent extremes. Two hells in one. It's so close in that its star looms 360 times larger in the sky than our sun. On Coro 7b, the first hell is unimaginably hot. The surface is a furnace, roasting at 4,700 degrees. Lava boils, turning the atmosphere into vaporized rock. When a cooler front moves in, small pebbles condense, and rocks rain from the sky.
If that's not a classic vision of hell, I don't know what is.
But that's only half the story. The hot side of the planet is locked, permanently facing the star. Beyond is the twilight zone. It's temperate here, cool enough to turn the lava oceans into solid rock. But this pleasant zone is narrow. Travel further, and you descend into a second hell. This is the dark side. The half of the planet that never sees the sun. Eternal darkness and savage cold. The temperature is hundreds of degrees below zero.
So one side is hot, another side is cold. You either have, fire or ice in the extreme, the coldest places in the universe and the hottest places in the universe. You couldn't think of a worse place to end up.
The planet was not always this way. Turn back the clock 1.5 billion years. Coro 7b is forming. But it isn't rocky. It's a gas giant, 100 times bigger than Earth. It migrates in toward its star. As it closes in, the star blowtorches gas from the planet. Its gaseous shell blasts off into space to reveal a rocky core. Coro 7b is the skeletal remains of a hot Jupiter. Its parent star has reduced this once massive gas giant to a rocky cinder. It's hard to imagine planets more extreme than Coro 7b. Yet they do exist. Rocky worlds, machine-gunned by deadly cosmic rays. This is a pulsar, 7,000 trillion miles away from Earth. It's a kind of cosmic lighthouse. This unbelievably tiny world, just 10 miles across, fires an intense beam of radiation through space as regularly as an atomic clock.
A single cubic centimeter, the size of a keyboard key, actually has about as much mass as Mount Everest. Smash a Mount Everest into a cubic centimeter, the whole star, which is only about 10 miles across, is like that.
It's one of the most hostile environments in the universe. Anything nearby gets hammered by intense gravity and magnetism. No one expected to find a planet here. But this pulsar has 3. Small, rocky, near Earth-sized. They were the first exoplanets ever discovered, and the last place you would ever find life.
It's got a tremendous magnetic field. It's blasting out X-rays, so these poor planets are just getting cooked by radiation. The word Earth-like, I don't think could be applied to these guys at all.
The X-ray beam strafes the planets over and over, firing radiation 1,000,000 times more deadly than medical X-rays. Slowly stripping their surfaces away. These are sterile worlds.
Everybody admits there's no chance for life, at least as we know it, on the planets that orbit the pulsar.
Radiation cooks pulsar planets to death. The opposite hell is no better. Frozen worlds too cold for life. In the constellation Scorpius, 20,000 light years away, is a red dwarf star. Red dwarfs are tiny and relatively cool. And this planet is too far away to fill what little heat there is. It's so distant, its orbit lasts 10 Earth years. It's the coldest planet we have found in the universe. Its surface is a frigid 370 degrees below zero. This is a world made entirely of ice. Methane, ammonia, and nitrogen are gases on Earth. Here they form a frozen, toxic frost. Glaciers and canyons and cliffs of ice are the only terrain. Here, hell really has frozen over. Our search for Earth's elusive twin reaches another dead end. Perhaps we are truly alone. Or will our first tantalizing glimpses of an alien world, potentially perfect for life, change everything? Earth, the only habitable world in our solar system. But in a galaxy of hundreds of billions of stars, can we really be alone? It's a question that planet hunters are trying to answer.
The whole purpose, in my opinion, of the discovery of exoplanets is to establish our true place in the universe. Who are we? Where do we belong in the cosmic scheme of things? Are there other planets that can have life just like ours?
That's where NASA's Kepler Space Telescope comes in. Kepler lets us calculate how far a planet is from its star. That's critical in figuring out whether it could sustain life. Life on Earth is only possible because we're the perfect distance from the sun, not too hot and not too cold. Just right for liquid water, oceans, rivers, lakes, rain, and life.
You know, journalists say, follow the money. Astronomers say, follow the water, because water is the universal solvent that dissolves most chemicals, and that's where DNA got off the ground. And where there's liquid water, there could be life.
We're looking for planets that are not too close to their parent star, where all the water would boil away, and not too far away from their parent star, where all the water would be tied up in a frozen form. We're looking for that Goldilocks zone, where the temperatures are just right for liquid water to pool on the surface.
Once Kepler has identified a new planet, astronomers check whether it lies in the habitable zone of its parent star. So far, Kepler hasn't found a single confirmed Earth twin. But it has identified more than 2,000 planetary possibilities. And it's this sheer abundance of planets that gives scientists hope.
The important thing to remember is that even though we're finding all of these terrible planets that are just completely unlivable, is that we're finding lots of them. We're finding hundreds and thousands of these planets. And what that's telling us is that planets are easy to make. And that means that even rare things are probably out there in large numbers. Even if the Earth is a rare, precious jewel in our galaxy, there may be dozens or hundreds of them out there.
Kepler has opened our eyes to a universe full of planets. We can now guess at how many there might be in our own galaxy. 50 billion. 50 billion worlds just waiting to be discovered. And we think 1% could be in the Goldilocks zone of their star. That's 500 million planets, each with a chance of harboring life. Right here on our own doorstep. We haven't found one yet, but we're getting closer. This is Gliese 581, a red dwarf star 20 light years from Earth.
Gliese 581 is a tiny little star. If the sun were the brightness of about a 100-watt light bulb, then Gliese 581 would be like a little Christmas tree light, a tiny little fairy light, very, very small. This shifts the life zone in, because now if you want to be warm enough, you need to snuggle up right next to the star.
The star has 4 planets. 3 are too close and hot for liquid water. But the 4th is different. It's a rocky world twice the size of Earth. And it's right on the edge of the Goldilocks zone. In theory, if the planet has a thick carbon dioxide atmosphere, it could trap enough heat to have clouds, rain, and oceans. It would be a strange place to live, twice Earth's gravity, bathed in permanent red twilight. But right now, this weird world is the closest we have to a planet like ours. It's a promising start.
When we actually know for a fact that up there around that star is a planet like Earth, that's going to just fundamentally change how people look at the sky and how people perceive their place in the universe. So that's going to be a profound moment, not just for me, but I think for humanity in general.
Our goal is to find another Earth, but along that path, we are going to find more things than we could have ever possibly imagined. And that's the part I love about this the most. We don't know what craziness is going to be around the next corner when we're looking for more planets. I can't even imagine.
Two decades ago, the only planets we knew were right here in our solar system. Now, there are hundreds, all very different from our home. The universe is filled with hellish worlds. Super hot, ultra cold, an ordinary star field, but home to one of the most extraordinary stars in our galaxy. 8.7 light years from Earth, this is UV Ceti. This mysterious object can grow 5 times brighter in less than a minute. Any planet circling this star would be blasted by the heat, quickly melting its frozen surface. Then, just seconds later, the sun dims. The planet retreats into icy darkness. But UV Ceti is about to go way further. The star begins to brighten, but this time, it doesn't stop. A runaway inferno, In just 20 seconds, it gets 75 times brighter than normal. UV SETI has unleashed a mega flare, an immense explosion of energy on the star's surface. If our sun fired off a mega flare like this, we'd be toast.
If you were standing on the surface of the Earth and the sun were to get 75 times brighter, even for only a minute or two, it would really probably be the last thing you'd ever see. The temperature on the Earth would rise up, we'd have huge fires, it would just basically cook everything.
Earth is a long way from UV SETI. We're safe from that particular star. But the more stars we study, the more flares we find. They fire in all directions. Sometimes directly at us. The closer a star is to Earth, the greater the danger. And one star is way closer than all the others. Our sun looks stable and calm. But behind the glare, the sun is a monster. Solar observatories capture the violence. Flares erupt across its surface. Gigantic explosions on an unimaginable scale.
One flare, one of the most energetic flares on the surface of the sun, would be equivalent to over 200 million hydrogen atomic bombs. It's enough energy to power the entire human race's energy consumption for something like 2 million years.
Each flare is as bright as 400 billion trillion light bulbs. But the visible light is just a fraction of the energy it emits. Radio waves, infrared heat, ultraviolet light, even X-rays, unleashed in every flare at incredible intensities. These are the biggest explosions in the solar system. Yet the force behind them is simple. Magnetism. The sun has an immense magnetic field. The energy stored in this field powers solar flares. Vast loops of magnetic force push toward the surface. Huge magnetic arches rise out into space. When two field lines cross, it triggers a magnetic short circuit. This is a solar flare. All the energy trapped in the magnetic field blasts out at 100 million degrees. It can hurl hot gas 1 billion miles out into space. An eruption 10 million times more powerful than a volcano. Magnetism. The same force that powers a simple compass fuels the biggest explosions in the solar system. Yet by cosmic standards, our sun is puny.
As we look out into space, we see even more active stars, even more intense magnetism, and then things really start to get wild.
There are stars and objects in our galaxy and in other galaxies that produce flares at great intensity, so great they would literally destroy all life on Earth if they were nearby.
Outside our solar system, titanic explosions rock the cosmos on a scale we can barely imagine. Far beyond the sun, we enter the realm of megaflares. Our sun is violent. Flares explode with the force of billions of atomic bombs. But travel out into the cosmos, and the explosions get bigger. Other stars have flares so huge, they're planet killers. EV Lacerti is 16.5 light years from Earth. Every day, flares erupt on its surface. But one megaflare smashed every record. The star blasted out 10,000 times more X-rays than the sun's most powerful flare. The ultraviolet light was so intense, the star turned blue. This stellar firestorm, 100 trillion miles away, was visible from Earth with the naked eye. If our sun flared like this, we'd be incinerated. But EV Lacerti is a very different kind of star. Compared to our sun, it is tiny. This is a red dwarf.
Red dwarfs are stars that have much less mass than the sun. They can be 1/10 to about 4/10 the mass of the sun. They're smaller, they're cooler. These are dinky stars.
They burn so slowly that unlike our sun, which will last 10 billion years, some of them will last 10 trillion years.
They're also relatively cold. Their surface is just 5,000 degrees Fahrenheit, half the temperature of our sun and 10,000 times dimmer. Yet somehow, they're capable of staggering violence. That's because red dwarfs are immensely magnetic. The fields which form inside them are enormous, much more powerful than our sun's.
That means the magnetic field energy that can be released when those fields get twisted up is incredibly intense. And even though these objects are very dim in visible light, they can produce flares that are thousands of times more energetic than those released by the sun. You wouldn't want to be near one of those when it went off.
All red dwarfs flare violently. But E.V. Lacertes' flares are off the chart. That's because it's young, just 300 million years old. 15 times younger than our sun.
In one way, stars are a little bit like people. They're hotheads when they're younger. When stars are first born, they're spinning very rapidly, and that actually helps generate magnetic fields as well.
The result: a star 100 times more magnetic than the sun. When its giant loops cross, the megaflare is colossal. A torrent of radiation lasting 8 hours. Big flares on our sun have the energy of billions of atomic bombs. E.V. Lacertes' monster flare was 10,000 times more powerful. Incredibly, even these massive flares are just a flicker on the cosmic scale. There are eruptions millions of times brighter. Explosions that can light up a whole galaxy from a tiny star with unimaginable power. This is the Australia Telescope Compact Array, a network of 5 radio dishes constantly listening to the cosmos. In 2004, they were struck by a massive blast of energy. Evidence of a megaflare. But this was bigger than any we had witnessed before. The largest burst of power ever recorded from our galaxy. The object behind it is truly bizarre. A kind of star we didn't even know existed, until a megaflare gave it away.
I've studied black holes. I've studied stars that explode. I've talked about rogue planets wandering the galaxy. For my money, the scariest single object in the galaxy is a magnetar.
Magnetars are the most magnetic objects in the universe. And this one beats them all. Its magnetic field is 1,000 trillion times stronger than our sun's. If it came near our solar system, the effects would be devastating.
The first thing you would notice is its magnetism would wipe every credit card in your pocket. As you start to get closer, anything metal on you would be ripped away, your earrings, your jewelry. Once you got within a few million miles of the magnetar, its magnetism would be so intense it would actually disrupt the electrical signals in your nerves and your heart would stop beating. Get even closer and the magnetism would be so intense it would rip apart every atom in your body.
Amazingly, this vast magnetic field comes from an object no bigger than an asteroid. Our sun is close to 1 million miles across. The magnetar? Just 10, but it's unimaginably dense.
It weighs more than the sun. This is incredible. Take the sun and squeeze it down, not just to the size of the Earth, but down to the size of Manhattan.
The entire mass of a gigantic star packed into a space the size of a city.
You could almost walk around the star in a day, except you couldn't because the gravitational field is so intense. The density of material on these stars is so great that a teaspoonful of material weighs several thousand billion tons. You would be crushed beyond recognition in a moment.
Dense and compacted, the iron-rich crust is under incredible magnetic pressure. Something has to give. Fissures rip across the surface. The crust splits open. A starquake.
It's like an earthquake on Earth, except the crust literally moves a half an inch. It's just a little tiny shift. But that is a huge amount of energy because of this intense gravity. It's like a magnitude 30 earthquake.
A flare erupts from the fracture. A trillion-ton cloud of ultra-dense matter blasts into space. It lasts just 1/10 of a second. But it unleashes more energy than the sun emits over 250,000 years.
The energy emitted when one of these flares from a magnetar is released, in some cases more than 1 billion times the energy emitted by the sun.
Megaflares are time machines. They show us events from long ago. This magnetar is 50,000 light years from Earth. The flare we observed in 2004 actually happened 50,000 years ago. It took that long for the light to travel halfway across the galaxy and slam into our atmosphere. If a similar megaflare exploded near Earth, we wouldn't even see it coming.
We would have no warning if a magnetar were to have another flare like this. The event is so sudden on the surface and it creates so much energy, it blasts out at the speed of light. And nothing can travel faster than light. So basically, this just happens, and that's it.
Any life within 10 light years of the blast would be vaporized. Thankfully, even the closest magnetar is too distant to threaten us. We can't see them, even with the strongest telescope. We've only detected these stars in the flash of a megaflare. Yet these explosions are dwarfed by an even more powerful monster. Second only to the Big Bang in scale, this is the ultimate megaflare. $7.5 billion years ago, many galaxies away, a supergiant star is in trouble. Its nuclear core has run out of energy. It's about to implode. For a few seconds, the colossal blast shines 1,000,000 times brighter than our entire galaxy. This is the most extreme explosion in the universe. A gamma-ray burster.
Gamma-ray bursters are so powerful that they can be seen across the entire universe, second only to creation itself.
Two intense jets of energy shoot out. These two beams of gamma rays are the ultimate mega flare.
And the energy of these things is just unimaginable. It's the entire power that the sun puts out over its entire 10 billion year lifetime, focused into just these two things that last for maybe a few seconds. It's like a cosmic blowtorch of gamma rays and matter that march across the universe.
The most high-energy, intense light is gamma rays. Gamma rays are naturally produced by things that are billions of degrees hot. There will never be a hotter type of flare. This is where it stops. Gamma rays is it.
7.5 billion years after the explosion actually happened, we see it in our skies. March 2008. A flare from halfway across the entire universe shines even more brightly than the closest star.
Something blew up 7 billion light years away that you could see with your unaided eye on a dark night. That should tell you something.
It is the biggest flare ever witnessed. But it is also a sign of the birth of the most destructive entity in the universe. A black hole has formed in the core of the collapsing star. It consumes the star from the inside out. When the star finally explodes in a catastrophic supernova, all that remains is a newborn black hole.
Usually when we look in outer space, we see old black holes that have been around for millions of years. But to see a baby black hole being born, that is an incredible event, and that's what we think is a gamma-ray burster.
Amazingly, these gigantic explosions are common. We see more than 350 a year.
We see them every day. Our satellites detect them every few hours in all directions outside the Milky Way galaxy.
Gamma-ray megaflares reveal one of the universe's most awesome secrets. A new black hole is born every single day. Most of these explosions happened a long time ago, far away from Earth. But if one went off inside our galaxy, it could be catastrophic.
If you were to put a gamma ray burst 100 light years from the Earth, it would be like igniting a 1 megaton nuclear bomb over every square mile of the surface of the Earth facing that event. You would be blowing up millions and millions of nuclear weapons over the planet. It would be the end of all life on Earth as we know it forever.
Gamma ray bursts are the most powerful megaflares in existence, but not the most dangerous for us. The greatest threat to Earth sits terrifyingly close, right at the heart of our own solar system. We were once blissfully ignorant, safe in our solar system. Now we know Earth sits in a cosmic firing range. Monster megaflares are everywhere we look. But the deadliest cosmic weapon of all is right on our doorstep. Our sun.
We're lulled into thinking that the sun is static, is benevolent, and is our friend. Wrong. The sun is dynamic. In some sense, it's alive. It creates magnetism on a scale that we can only begin to comprehend.
And its most powerful weapon is this: a coronal mass ejection, or CME. A colossal solar explosion rips a chunk of the star away and torpedoes it out into space.
Coronal mass ejections are related to flares, but they're even larger.
You can sort of think of it as a solar flare being like a tornado. Very powerful, very intense, very short-lived. And a coronal mass ejection is like a hurricane. Much more energy, much bigger, and can last for days and days.
CMEs start with a magnetic short circuit. Magnetic arcs emerge from the surface, glowing with trapped solar matter. The loops cross, triggering a firestorm of energy. The sun erupts. Solar matter explodes from the surface, out into space. A monstrous cloud of superhot gas and electric particles.
When one of these huge prominences is shot out, an energy equivalent of about 10% of the entire luminosity of the sun for a second is released towards the Earth. Over 10 billion tons of material is shot out at a speed of over 1 million miles an hour.
The power of a coronal mass ejection is sort of mind-numbing. It takes our probes years to get from the Earth to the sun. A coronal mass ejection can cross that distance in a couple of days, sometimes in only a couple of hours or even faster than that. So these are tremendously powerful events.
Powerful, but also deadly. Because sometimes the sun shoots a CME straight toward the Earth. The crackling, charged cloud plays havoc with our electronics. It melts power grids, blows fuses, and disrupts communications. But that's nothing compared to the damage that a really big CME could do.
They can wipe out satellites, GPS, the internet. All sorts of havoc can take place when this huge tsunami hits the Earth.
The damage to satellites alone would total $100 billion.
Think of a blackout that hits not just one city, but hundreds of cities around the planet Earth. Property damage would be about $2 trillion. We're talking about perhaps a collapse of modern-day civilization. We're going to be thrown back perhaps 50, 100 years into the past, into a world without electricity.
Big solar storms are rare. On average, a massive CME strikes Earth every 500 years. But it's happened before, and it will happen again.
In 2003, we had one of the largest coronal mass ejections ever recorded, but fortunately, it missed the Earth. One of these days, it's going to hit the Earth. One of these days, one of these rifle bullets will be aimed right at the Earth, and at that point, watch out.
Our planet is under attack. Not just from megaflares in deep space, but from our own star. The sun fires billions of tons of hot gas and electric particles into space every day. Deadly solar weapons. Sometimes pointing straight at us.
What I find amazing is the fact that the Earth is in the middle of a shooting gallery.
But we have survived this onslaught. We are protected. The Earth has a magnetic field. It's incredibly weak, but enough to keep us safe.
Think of an ordinary magnet that you use on your refrigerator. That has more magnetism than the Earth's magnetic field.
Without our magnetic shield, every CME would strip away Earth's atmosphere. And we'd be fried by solar radiation. How do we know? Because it happened to one of our neighbors.
Look at Mars. Mars is an example of what happens to a planet without a magnetic field. Mars is a frozen desert with an atmosphere only 1% the atmospheric density of the Earth. It's because it lacks a magnetic field.
Over billions of years, these particles have actually stripped away Mars's air, and that's why it has very thin atmosphere now. Here on Earth, we have a magnetic field and we have air. This is not a coincidence. So we can breathe because of our magnetic field.
From Earth's surface, safe beneath our magnetic umbrella, we see the power of our violent sun in the northern and southern lights. Trillions upon trillions of electric particles strike the Earth every second. The magnetic shield funnels them to the poles. They energize gas molecules in our atmosphere, making them glow. A chemical light show. Oxygen shines green. Nitrogen, blue or red. The aurorae are evidence of a battle between magnetic fields. The sun's field creates CMEs. Earth's field shields us from them. Magnetism is nature's most mysterious force. Only now are we beginning to understand how it shapes the cosmos. Megaflares make magnetism visible. They shine a light on the incredible power of magnetic fields. Fields that play a fundamental role in the universe. They impose order on chaos. They weave their way through the spiral shapes of galaxies. Fields hundreds of thousands of light years across, yet 100,000 times weaker than Earth's. Smaller magnetic fields exist inside galaxies. They organize matter into clouds of molecules, spectacular nebulae. These stellar nurseries are where new stars are born. Now we've discovered magnetic fields even permeate empty space. Fields created in the Big Bang with just 1/quadrillionth the strength of Earth's. This is a magnetic universe.
What's amazing is this thing that's invisible, magnetic fields, play such an important role in every aspect of the universe, protecting us from the radiation from the sun, to the explosions in red dwarfs, to magnetars, and to the most energetic, violent processes in the entire universe, gamma ray bursts. Magnetism plays a role on every scale of the universe, changing the dynamics of objects and making the universe a violent and interesting place.
Mega flares light up the cosmos. They show us things we can't otherwise see. From the other side of the universe, or from billions of years in the past, a black hole is born. A star dies. Distant events and hidden mysteries. In a flash, flares reveal them, illuminating the awesome secrets of the universe.